Today I'm going to show you how to find the hydraulic conductivity of a specific soil using RETC. So the first thing you're going to need, obviously, is the RETC program. So you can just go on to Google and type in RETC and you should come up with this PC progress page. They kind of go through an overview of the program. There's a great little PDF that you can download that outlines all of the equations and parameters for RETC. So you can take a look at that, but what you want to do is go down here to RETC downloads, click on that link, and you can go ahead and click RETC and download it there. Now just a note, RETC does not run on any Apple products, so you're going to need a Windows computer in order to run that program. Once you have RETC downloaded and you open it up, this is what it should look like. It should just be a blank screen, and you can go up into File, Project Manager, and you can pick any kind of example problems that you want. But for our sake, we're going to go ahead and use this forward problem. And so this is what it typically looks like. So you have a bunch of different options to change all of these items. I'll go ahead and show you how to do that. For this example 1, which is the forward problem in RETC, you're going to need certain parameters, soil parameters, and you can gather those either in the field or through this really handy web application called Web Soil Survey. It's from the NRCS, and all you have to do is just type that into Google again, and then it'll pop up this page. You're going to want to hit Start WSS. And if you've already been here before like I have, that'll pop up. But here you can go and pick any point in the US, or if you have some kind of shapefile, you can go ahead and create this area of interest using that shapefile. And then we set our area of interest. So here's my area of interest, it's just a field. And then we can go ahead and explore the soil data from there. So if you don't have any kind of in-field measurements for some of the input parameters, this is your best option. All right, now heading back to RETC, we're going to go ahead and double-click on this type of problem. So this is one that I've already set up for this Lank Bush Brent sandy loam soil, so that's what I'm going to use. And for this type of problem, we're going to want to hit this no fitting forward problem. So that just means that RETC is going to provide all of the calculations that it has to give us the soil hydraulic conductivity of the soil we're interested in. So once that's set up, you go ahead and click Next. And this is really just up to you. It's just the units of your soil hydraulic conductivity and other output parameters. So we're just going to leave it on centimeters per day for now, but you can totally change it into whatever works best for what you're using it for. So we click Next, and it should be set at this Van Genuchen m equals 1 minus 1 over n. So that's our type of model that we've chosen. Here are the input parameters for our soil. So this is where we get into the specifics for each soil that we're going to look at. And typically it will have this little drop-down box, and if you want, you can go ahead and click just their pre-programmed general calculations and estimates of all of these input parameters by soil type. But you should probably just go ahead and using Soil Web Survey, we can gather a lot of this information. So just as an explanation, QR or theta R is our residual water content. And so that's going to be our soil water capacity at wilting point. And then QS or theta S, that's going to be our saturated soil water content, and that is our soil at field capacity. Alpha is one of our other input parameters, which can be solved as 1 divided by this theta S, so that's really simple. N is a measure of soil porosity, and that's going to be 1 plus your general soil porosity equation, right? So that's going to be 1 minus bulk density over the soil particle density. And then I and Ks, I you can just leave as 0.5, and Ks is going to be solved using this neural network prediction. So I mentioned we can get a lot of information from the Soil Web Survey. So this is where you use the percent sand, silt, and clay contents and the bulk density that the Soil Web Survey provides for your specific soil. And you go ahead and enter these terms in. You'll hit predict, and then you'll hit accept. So we can just go ahead and make one up real quick. Do 25, 50, 25, and we'll make our bulk density a general 1.33. So then I would go ahead and hit predict, boom, and it gives me these parameters that it predicts. Then you want to hit accept. So I would do that first before you enter in any of these 3 or 4 parameters. It's just easier because once you hit this neural network prediction, it'll kind of change things up on you. So we'll just assume that these are all correct for our soil, and then we'll go ahead and hit next. Do you want to save the input data? Yes. And then it asks, do you want to run it? Click OK. Comes up with this little box. You just hit enter. And then it'll come up with your post-processing couple of tabs here. So here are some options to create graphs of some of the outputs. So you can change your X and Y axes to a bunch of different things. So I'll change my X to water content, and then we'll go ahead and change that to hydraulic conductivity. So you can look at it in a graphical form, or you can go ahead and look at the output file. So here's all of our input values, and then it comes out with all of the output values that they use to graph what is written above. And that's pretty much it for RETC predicting our soil hydraulic conductivity. Now, one last thing is some extra bonus content here. Real quick, how you open up a previously made RETC file. They should show up as like .ret files. So you're going to want to go up to Project, hit Open, and we'll go ahead and open up this Brentlohm file. All right, and there you go. You can go ahead and double check our soil parameters. All good to go. Run RETC. And there's your output. So if somebody sends you any files, or if you want to check on some previously made files that you've done, that is how you go ahead and do it. And you can go back in then and tweak any parts of the pre-processing tabs, whatever you want. Thanks for watching.